Hey, welcome to Passages in Applied Mechanics by Dr. Lorenzo Garcia. Today, Dynamics. Work and Energy, Introduction. Once we discussed introductory concepts in kinetics, such as kinetics and inertia. Let's talk about the concepts of work and power as they apply to linear and rotational motion of moving objects and mechanical components. The concept of mechanical energy is one of the most useful in engineering. Many devices are used to convert mechanical energy to or from other forms of energy, e.g. an electric motor converts electrical energy to mechanical energy, an electric generator converts mechanical energy into electrical energy, and a heat engine converts heat to mechanical energy. However, do you know the meaning of the word energy is very different from its scientific meaning? Before discussing it, let's define a few concepts. Mechanical work. Have you ever wondered about the work done by a crane to lift a vessel? Or the work done by a truck to transport 3 tons of bottles inside? Mechanical work is defined in terms of linear or rotational effort when the result produced by the effort is the movement or rotation of a body. Are you able to visualize the effect of a force against a body according to this representation? It moves, right? In linear motion, if a force F is applied to a body which moves in a straight line a distance s in the direction of the force, then the work W done by the force on the body is said to be the product of the force and the distance. From this definition, what is the unit of work? Exactly, force in Newton and distance in meters, then the unit of work is the Newton meter. Which it is equal to joule in the International System of Units, and it is denoted by the capital letter of J. In rotational terms, torque T is analogous to force. Similarity angular displacement, theta, is analogous to linear displacement. This analogy can be used to arrive at the expression for work done by torque on a rotating object. Since torque is measured in Newton meters and angular displacement in radians, which are dimensionless, it can be seen that work done by torque can also be measured in joules. Power. What is the power of your washing machine? What is the power of a rugby player? What is power? When work is being done continuously over a period of time, the time rate of doing work is called power, P, where P is average power, W is the work done and T is time taken to do the work. The unit of power is equal to 1 joule of work per second of time, given a name of watt. Be careful to avoid confusion between W, as a symbol for work done and W, as unit symbol for power. Mathematically can be expressed then as. In many practical situations, mechanical work is done by a force whose magnitude does not remain constant over the entire period during which work is being done. In these cases, it is possible to consider the relative simple but useful case of work done in deforming a coil spring. In this case, it is found that within the normal operating limits of the material, the force required to produce axial compression or elongation of the spring is directly proportional to the amount of the formation, which can express as a formula, where x is the amount of elongation or compression, F is the force corresponding to the amount of deformation, and K is the constant of proportionality, or known simply as spring constant. Let's apply these concepts to solve engineering problems. Dr. Lorenzo Garcia here, thanks for watching. Ciao.